Welcome children. So today we are going to learn about higher order derivatives. Among higher order derivatives, we will be dealing with second order derivative. Let us first understand what is meant by second order derivatives. Say we have a function y which is written in terms of x as fx. Then derivative of y with respect to x we generally denote it by dy over dx, and that of fx is denoted as f dash x. So this is the derivative of y with respect to x. That means once we have differentiated y with respect to x. Now in case f dash x is differentiable, then again going for differentiating this equation 1, you will find the left hand side reduces to d over dx of dy over dx. That means derivative of dy over dx with respect to x. Now this is called the second order derivative of y with respect to x. Now this notation, derivative of dy over dx with respect to x, this is also denoted as d square y over dx square, or with capital D with exponent 2 you can say d square y, or y double dash, or y2. In the same manner you will see this first derivative of y with respect to x, which is also written as f dash x, can also be denoted as y dash or y1. And if it is in terms of f dash x, its derivative with respect to x, that means we are doing the second order derivative, then the notation for it can be used as f double dash x. So these are few notations for second order derivative. In the same manner, if we go for differentiating it once more, the third order derivative will become d cube y over dx cube, or you can say f 3 dash we can have here, and then x. It can be termed as y3 also, or y with 3 dash. Okay, so these are some notations for higher order derivatives. Let us try some questions based on them. Now see here, we are given an equation which is y in terms of x. It says y is x square plus 3x plus 2, and you have to find the second order derivative of these functions. Fine, so let us differentiate it. Differentiating both sides with respect to x. So derivative of y will be dy over dx, that of x square is 2x, and that of 3x is 3. Then differentiating again with respect to x, because we have to find the second order derivative. So differentiating again with respect to x, this will become derivative of dy over dx with respect to x. Okay, so we will write it as d square y over dx square is equal to derivative of 2x, which will be 2 only, and that of 3 becomes 0. So you can see the second order derivative is coming out to be 2, which is a constant. Now checking for the next one, if y is x cos x, then we can differentiate it using product rule. So derivative of y with respect to x, keeping x as it is, derivative of cos x is minus sin x, and then keeping cos x as it is, derivative of x is 1. So this is our first order derivative. Then differentiating again with respect to x, we get d square y over dx square is equal to, here we need to apply, while differentiating this part, we need to apply again product rule. So minus, I am keeping x as it is and differentiating sin x. Derivative of sin x is cos x. Then minus, keeping sin x as it is, derivative of x will be 1. This minus sign because of the term which was negative here. So keeping sin x as it is and differentiating x, whose derivative happens to be 1. Then the second term in the expression, which is cos x, its derivative is also minus sin x. So we can add up the like terms, and we finally get d square y over dx square is equal to minus x cos x minus 2 sin x. On to the next one. See, slightly the form has changed. We have to find the second order derivative and we have to reduce the equation into a certain form. Let us see how to do it. Because it involves second order derivative, so it is obvious we need to differentiate it twice. Now derivative of y with respect to x, derivative of 5 cos x will be minus 5 sin x, and that of 3 sin x will be 3 cos x. Done with the first order derivative, moving on to the second order derivative. So derivative of 5 sin x will be 5 cos x, and that of 3 cos x will be minus 3 sin x. So this reduces to plus. So plus 3 sin x. Now over here you will find on the right hand side, if we take minus sign common, it is 5 cos x minus 3 sin x. And this term within the bracket is nothing but y. So what are we getting? D square y over dx square is equal to minus y. Now shifting this y to the left hand side, we meet the required condition, that is d square y over dx square plus y is equal to 0. So the proof. Now see another one. Here y is defined as cos inverse x and they are asking you to find dy over dx only in terms of y. So we can do some rearrangement here. We can write y is equal to cos inverse x as cos y is equal to x. Now we can go for differentiating. So differentiating both sides with respect to x. So differentiating cos y. Derivative of cos y is minus sin y, and then derivative of y is dy over dx. On the right hand side it is x, so its derivative will be 1. Now we can cross multiply this minus sin y. So 1 over sin y will be cosec y. So dy over dx reduces to minus cosec y. Now differentiate again with respect to x. Differentiating again with respect to x. The derivative of dy over dx will be d square y over dx square minus derivative of cosec y is minus cosec y cot y, and then derivative of y, which is dy over dx. So this minus and minus becomes plus. We get cosec y cot y, and we put the value of dy over dx. So you see what dy over dx was. It was minus cosec y. So finally the second order derivative reduces to minus cosec square y cot y. So you can see the derivative is entirely in terms of the variable y. Fine. Now let us do another one. Over here y is defined, you can see, and you have to show this equation. This is to be met, this is to be proved. So y2 is denoting here second order derivative, y1 is first order derivative. So it is understood we need to differentiate it twice. Let us go for the first order derivative. Let us see what we get. Dy over dx will be minus 3 sin log x. Derivative of cos log x will be minus sin log x. And then derivative of log x will be 1 over x. And in the next part, 4 times derivative of sin log x, which will become cos log x. And this entire term divided by x. Now in place of this dy over dx, you can even write y1. And if we cross multiply this x, which is in the denominator on the right hand side, we get expression for xy1. It will become minus 3 sin log x plus 4 cos log x. Now differentiate once more. Differentiating again with respect to x. So both sides we are differentiating with respect to x. Now left hand side, if you see two functions are getting multiplied, so we need to apply product rule. So keeping x as it is, derivative of y1 will be y2. Then keeping y1 as it is, derivative of x is 1. Now on the right hand side, we have minus 3, which multiplies with derivative of sine log x, which will be cos log x. And then derivative of log x will be 1 over x. Then the next part, it is 4 times cos log x. So 4 into derivative of cos log x, which will be 4 into minus sine log x, and the derivative of log x is 1 over x. Again, you can see the denominators are same. We can multiply the entire equation by x to get rid of these x in the denominator. When we multiply the entire equation by x, we get x square y2 plus xy1 is equal to, over here we can take minus common. So we get thrice of cos log x plus 4 times sine log x. Now you look at the term inside the expression inside the bracket. You will find it is nothing but our function y only. Okay, so you can replace it by y and we get x square y2 plus xy1 is equal to minus y. Bringing it to the left side, we get the required equation which is to be obtained. X square y2 plus xy1 plus y is equal to 0. So done with the proof part. Another one of the same kind. This is what is to be obtained. Y is given as a times e to the power mx plus b times e to the power nx. So we'll be differentiating it twice. We'll find dy over dx as well as d square y over dx square. Now first going for dy over dx. It will be a times derivative of e to the power mx, which is e to the power mx, and then derivative of mx will be m. In the same manner, in the second part, b into derivative of e to the power nx, which will be e to the power nx multiplied with n. So dy over dx is obtained. Now the second order derivative. So m times a we are already having as a scalar. It multiplies with derivative of e to the power mx, which is e to the power mx, and then derivative of mx will be m. So one more m we are going to get here. So this reduces to m square. In the same way, in the later part, nb into derivative of e to the power nx, which is e to the power nx only, and then multiplied with n. So this reduces to n square. Now, because in this form it is difficult to convert it to the required form, so in the left hand side you can substitute dy over dx and d square y over dx, d square y over dx square. So if we substitute both and simplify it, it should come out to be 0. So substituting for d square y over dx square, it is m square a times e to the power mx plus n square b e to the power nx. Then it is minus m plus n times dy over dx. So you see what dy over dx is. It is ma e to the power mx plus nb e to the power nx. And then m into n into y. Y is a into e to the power mx plus b into e to the power nx. So this entire expression we need to expand. Because the right hand side is 0, so obviously all the terms need to be cancelled out. So let us expand it. First we'll multiply n with both, minus m with both. So we get minus m square a e to the power mx and then minus m n b e to the power nx. Then multiplying both these terms by minus n, we get minus m n a e to the power mx and then multiplying, this is mx children, okay, then multiplying minus n with n b e to the power nx. So it will be minus n square b e to the power nx. Now coming to the last part, multiply mn with both of them, we get plus mn a e to the power mx plus mn b e to the power nx. Now have a look, you will find each of the term is getting eliminated. You can see this m square a e to the power mx cancel out with this one. positive as well as negative of the same term. Then this gets eliminated with this one. These two are eliminated. These two are eliminated. You can see all the terms get cancelled out and it is reduced to 0. That is the right hand side. One quick last one. See here. We are given y as square of tan inverse x. Okay, you can see we are involving both the derivatives y1 as well as y2. So quickly finding for them. Y1 will be its derivative. Okay, it will be first 2 tan inverse x and then the derivative of tan inverse x, which is 1 over 1 plus x square. Now before going for differentiation in this form only, we can simplify this expression. We can cross multiply 1 plus x square and we get 1 plus x square multiplied with y1 is equal to 2 tan inverse x. Now differentiating again with respect to x. So you differentiate both the sides. Here we'll apply product rule. So keeping 1 plus x square as it is, derivative of y1 is y2. Then we will keep y1 as it is and differentiate 1 plus x square. Derivative of 1 plus x square will be 2x. Moving on to the right side, 2 into derivative of tan inverse x, which is 1 over 1 plus x square. Again multiplying the entire equation with 1 plus x square. We get 1 plus x square whole square y2 plus 2x into 1 plus x square y1, which is equal to 2. Now compare it with the expression given to us, equation given to us. You will find it is the identical equation. So the proof is done. Hence proved. Now children, you can see we have done plenty of examples. Based on that, you can try this practice assignment.